All right, well, hello everyone. This is Rebecca Dallin, Assistant Superintendent of Stormwater Quality here at the City of Oklahoma City. I would like to officially welcome everyone to our sixth installment of this Floatables webinar series. We will begin momentarily, so I wanted to take some opportunity to provide information to help enhance everyone's experience during the presentation today. In order to reduce background noise, we ask that everyone keep themselves muted during the presentation. If anyone has any questions during the presentation, feel free to type those into chat. Brooke, Varick, and I will be monitoring the chat for questions, and we will have our guest speaker answer as many questions as we have time for today. If anyone would like to receive a certificate of attendance for today's webinar, please send Brooke an email to request that. Boy, they've made a lot of changes to Teams. This is like really different. Oh, I clicked the wrong thing. This is really different. Okay, but I did find it, so congratulations. So just found chat. Hopefully all you guys can find that as well. Put that message in there. So if anyone has a question or if you'd like to receive that certificate of attendance, the information is now available in chat. Each of our presentations in this series will be available within a week or so after the scheduled live date on our website under Stormwater Workshops. And this section is called our 2021 Floatables Webinar Series. And of course, today's session will be the June edition. I will post a link to the website where you can get to those presentations toward the end of today's program. If anyone has any questions at this time, feel free to type them into chat. But without further ado, I will begin the very short Floatables series welcome presentation.
Good afternoon and welcome to our monthly Stormwater Quality webinar series. Since this is our first attempt at a themed series, we do hope that everyone is enjoying the presentations in this series and is learning something new. Our theme for 2021 is, as you know, floatables, blowable trash that could end up in a waterway or does end up in a waterway. During this series, you will have the opportunity to hear from several different guest speakers throughout the year, including the month of August, we'll hear from our Stormwater Quality Environmental section and from the Streets and Drainage Program's River Crew. Our environmental section has a program devoted to removing floatable debris from our local waterways, and they work in conjunction with the efforts of Streets and Drainage to remove debris from the Oklahoma River and other channels. September's program will include information from the city's water conservation program, in addition to information about trash and litter from utilities solid waste. We'll be rounding out the series with up-and-coming information from the city's sustainability program. This presentation in December will show how the planning department prepares for the future of our great city, including their plan to keep Oklahoma City just a little bit greener. We also have more traditional content for our industrial and construction stormwater permittees, while tying those subjects into the overall theme. As we've briefly mentioned, each of the presentations will be available online within a week or so after the presentation is aired. It will be available on the Workshops section of our Stormwater Quality website. I'll be posting a direct link to that page in the chat at the end of today's presentation. Some of our presentations will be live and some will be pre-recorded. We do our best to provide as much detailed, accurate information as possible while also working with the presenter's strengths and their schedule. We live and work in a beautiful community here in Oklahoma City. For more information about stormwater, what we're up to, and local regulations, be sure to visit our website.
All right. Up next is the main presentation for today's webinar. Today we're going to hear from Craig Schultz. He is employed by American Excelsior Company, Earth Science Division out of Arlington, Texas, as the Business Development Manager. Craig graduated from the University of Kansas, Rock Chalk Jayhawk. He has worked on numerous erosion and sediment control projects and has experience with rolled erosion control blankets, turf reinforcement mats, hydraulic mulches, alternative daily landfill cover, and other erosion and sediment control products. He's an active member of ASTM, where he serves as the chairman of a sediment control task group. Craig participates in the Erosion Control Technology Council. In addition, he is an industry member on the National Transportation Product Evaluation Program Technical Committee on Erosion Control Products and Sediment Retention Devices. Again, if anyone has any questions during today's presentation, be sure to type them into chat. Craig, if you would share your screen and begin your presentation.
Thank you. I will try to do that. It worked well on our demonstration yesterday. Rebecca, it's giving me the opportunity to just share my desktop window today.
Good times. Sometimes a fresh boot helps, but I won't have that opportunity. Hopefully it'll cooperate.
I'm going to click on this. Oh, there we go. Let's see here. Let's go. It just looked a little different than yesterday. Let's see what happens.
Yeah, I think changes happened overnight.
That was different than it looked yesterday. Can you see the presentation okay now?
Yes.
Oh, terrific. Oh, great. Okay. Well, it's always good when you can see it. And then that shut off my camera, so you can no longer see me, correct?
Yeah, I do not see you.
Okay, that's fine. Nobody needs to see me today anyway, right now. Well, thank you, everybody. Thanks for that introduction. For those of you, I've given this presentation in one format in the past, but it's a little bit, I would say, of a sister to the main topics of your floatables and your blowable trash. This is a presentation, Dam or Filter, that initially began as a presentation to help people understand, and you'll still see a lot of that in here, the types of products that you will see when it comes to sediment control out on the market. And what we learned from the last many, many years of this work and the committees we sit in on and so forth is there's a lot of misconceptions when it comes to what these products are. And so Rebecca and I were talking, and again, while it doesn't exactly match all the things you would deal with on this blowable trash side, I think there's some interesting characteristics that you might find interesting, and hopefully in the bigger picture of sediment control, you'll learn something today. So hopefully you'll find this all valuable, and we'll get started. If you have any questions, please, Rebecca or whoever, I don't mind if somebody jumps in. If I'm missing a comment or something in the chat, don't hesitate. So we'll see if we can get started. Okay, just a little bit about us, and this is not meant to be a commercial by any stretch, but I like to let people know who we are and where our knowledge base comes from. American Excelsior was formed in 1888. We started making packaging fibers. I tell everybody, if you've ever seen the Christmas Story movie and the dad pulls the leg lamp out of the crate, which is, I think, a hysterical scene, all that stuff he's pulling out of there is Excelsior fibers. And Excelsior was sort of the original natural packaging fiber, and it evolved over many years. We made things like they call them swamp cooler or evaporative cooler pads and things like that. And the company evolved into the 1960s in inventing the first erosion control blanket, Curlex 1. So Curlex is our brand name of Excelsior fibers. In the 1980s, we came out with the first double-netted erosion control blanket, Curlex 2, and the first heavy-duty erosion control blanket, Curlex 3. In the 1990s, the evolution continued. We came out with Erosionworks, which is a free design software you can download on our website to help you make decisions about what works best in your application in slopes or channels. We invented the sediment log, which we'll talk a lot about today, Quick Grass, which is our green pigmented products, and we built the Erosion Lab, which is the facility I run in Rice Lake, Wisconsin. In the 2000s, we developed a new turf reinforcement mat, or TRM, called RecycleX. We don't talk a lot about that today, but it's an interesting product in that all of those green fibers are post-consumer waste, and they are made from pop bottles, and they don't float, which is a really interesting characteristic for turf reinforcement mats. We invented our net-free product, which is the only net-free blanket of its type, and we came out with our e-staples, which are a biodegradable staple product. In 2012, we came out with Curlex blocks. This is another product we're going to talk about today. These were initially invented as an American-made alternative to coir logs for stream bank and lake bank restorations and filtering. And then most recently, in the 2018 timeframe, we came out with our newest group of turf reinforcement mats, called TriNet. So it's a little bit about us. I won't bore you with all the details of where we are, but as Rebecca said, our world headquarters is in Arlington there, and you'll see some different stars on the map. And the green stars are all erosion sediment control product manufacturing in Alabama, Ohio, and Wisconsin. Also, the facility I run is in Rice Lake, Wisconsin. And we have some other facilities there for other parts of our company. But needless to say, we're pretty diverse and have a lot of years of experience. Well, this is where I'm lucky enough to work and spend most of my days. My friends ask me what I do for a living, and I say, well, sometimes I'm giving webinars and training, and other times I'm playing in the dirt. And this is a facility it's larger than 25 acres, but 25, 35 acres of active things going on there, large pond, big diesel driven pumps there in the foreground. And we can run full-on ASTM level testing here. This is in Rice Lake, Wisconsin. We believe it's the largest privately owned research and testing lab of its type in North America and maybe the world. At the lab, we do large-scale ASTM performance testing, research and development, contracted testing, and lots of what we do there now is what I'm in charge of in the industry education seminars and internal and external training. We always invite people if they're ever in the area. We host a lot of events up here, especially in the summertime. And this year, though we haven't hosted one yet, we're actually making plans to host again, as most people didn't last year. But it's a great, great facility. We do a lot of testing there. Some tests you may have heard of are things like ASTM 5141, which has to do with filtering and sediment control devices. 6459, which are those slopes there on the right. Those are for rain simulation. We can simulate 2, 4, and 6 inch per hour rain events there that simulate real rainfall, where the raindrops reach terminal velocity and have the correct distribution and size and cover. So a lot of what we'll talk about in sediment control and erosion control comes from those. But then we also do D6460 testing and large scale testing. So the channels you'll see on the left. So it's a lot of fun. It's a really great place. And as the cartoon says, we prefer to think of it as added value. And I share that, again, it's not as a commercial, but to let you know that we take this really, really seriously. And we try very hard to give presentations and participate in events that makes our industry better. And if you ever have questions or comments or want to visit, please do not hesitate to reach out to us. We'd love to have you at the facility. And as someone was saying at the beginning, it's nice to see people in person again. I won't go into all these things, but just so you know, when you go to our website, we have a huge technical support library where you can get everything about CAD details and staple patterns and cross references. We have, I think, a pretty nice YouTube channel. It's getting better every day, where we're adding in videos that talk about just everything, different things about fibers and different things about installation techniques and those sorts of things. And we try to build them in a way that is useful to anybody, right? Anybody who's using that sort of a product, whether it's ours or not. We hope you find that to be useful to you and your coworkers. Erosionworks, I mentioned earlier, we don't go into that today, but it's a free software. You can download it. We don't sell your name or do anything with it. It just allows you to populate information about your slope or your channel. It gives you good, better, and best recommendations. So it's a really neat software to help you kind of get you in the ballpark. If you have some pricing on the materials you're thinking about using, it'll even help you do calculations on cost and tell you how many staples to buy for blankets. So pretty neat. And again, all this is free, and we don't sell your name or do anything with it. If someone signs up for Erosionworks, we usually reach out and say hello and make sure you don't need anything. But that's the extent of the marketing that goes along with those tools. So please take some time to check that out. So, the trash on the right is something we've all seen. And a lot of what I'll talk about today is how these things and how these blowable products and so forth end up in the water streams, because that's what I deal with primarily is what happens when they get in the water, or what happens when the water breaks free. And, at the end of the day, what we're trying to do is we're trying to control sediment. On the left, that drain's not going to do much good anymore on the left, and the sewer really does not prefer to have soda bottles drop down in it and leaves and branches. So what can we do about that? What products exist? And that's a lot of what we're going to talk about today. Specifically, when you put a product in these situations, whether it dams or filters the water, why does that matter? And so hopefully you'll find some value in that. So obviously the bale checks upstream of this, there were bale checks. You can't see them in this picture, but just up there were some bale checks, and they frankly weren't doing their job. But that's not because bale checks are inherently bad. It's just that they don't filter water. The sediment-laden water and any other pollutants are coming right down the stream, and they're polluting, whether it's sediment or whether it's trash or what it is, there's a pollutant. And so what I talk about today isn't really a good or bad thing. It's just how these products perform differently, and then how if you use the right best management practice for BMP in the right application and you install it correctly, it'll generally work. But that we shouldn't lump them all together and assume just because they have a similar look that they perform in a similar manner. You probably all know this, but I always like to say some of these basic things at the beginning. You know, people talk about erosion and sediment control very quickly and they just move past it. What we want to talk about today, though, while it doesn't necessarily pertain directly to your floatables and some of those things, erosion control prevents the need for as much sediment control. You know, preventing products, the soil and so forth from breaking away in the first place minimizes the need to capture it when it breaks away. So erosion control is keeping the dirt in its place, and sediment control is what we're doing to remove those soil particles that have eroded away. So basic stuff, but it's something to keep in mind. So I'm sure you've all unfortunately seen pictures like this. And the trash in the ditch there, right? At some point, that was blowing around or floating around because of lots of reasons in this particular picture, but lots of reasons in many different applications that the trash is going to end up in a place we don't want it. It's going to end up in the sewers. It's going to end up in the roadways. It's going to do a lot of harm in one way or another. And what can we do? What exists out there to help minimize these things? And there was no erosion control, obviously, on the site. Maybe it wasn't in the stage where that could have happened. So they tried to do a little bale check there above the arrow, but there really wasn't any erosion control. Doing things correctly, installing some products, even if it wasn't time for erosion control, installing some sediment control products would have caused this to look a lot different. Doesn't mean you wouldn't have had any, but we could have kept all of that trash and most of that, if not all of that soil, out of that ditch from clogging that pipe. So this isn't a question that you have to answer out loud, but a lot of the rest of this presentation is going to talk about densities of products and whether something dams water or filters water. And so what I want you to consider is, does the density of a sediment control product or device affect how it performs? And the answer is yes. But why does it matter? And this is what we're going to talk about. Why does something that looks very similar, it's a tubular shaped product for instance, and it's 12 inches in diameter. Why does it matter? Why does it matter what's inside of it? And why does it matter whether it dams the water or filters the water? And then what does that mean for you all when you're talking about waste, not only blowable trash, but what about the other contaminants that are coming along with that water? So when we talk about filtering and damming products, just as a reference, we classify filtering products that have a flow rate of 35 gallons per minute per square foot or more. So they allow at least that much water to flow through their matrices, and they're providing some velocity dissipation when that flow rate's exceeded, and they also are capturing some sediment and waste and so forth within their matrices in many conditions. Damming products are not that, obviously. So they have a flow rate of less than 35 gallons per minute, and they're designed to pool water. So these have different end results, right? They may be they're both looking in the sediment control world of keeping sediment under control, but they do it in very different ways. And we think there are ways that are better than others. So the world's simplest video, I just want you to look at what happens to the water when it's poured over these two products. We make both of these products. One of them is a straw wattle that I'm sure you've seen, and the other is our Curlex sediment log. So the sediment log is a filtering product, and the wattle is a damming product. So here the water goes off the sides of it. It doesn't flow through it. So these would dam the water. same dimensions here, and see how the water flows through it. You say, well, like, who cares, Craig? Why does that matter? So that's what we're going to talk about next. And I think it can have some positive impacts on the not only the regular sediment that you would consider the sort of the traditional dirt in your runoff, but I think it could also help with some of the trash and blowables that you all run into. So the point of this picture, I know it's not the greatest picture. I blew it up a little more than I wanted to, but to get the point, the point of this is simply to show you what a filtering product can do. The trash and debris they're not out in the street, right? And if the water would have pooled significantly, what we see in the field is the pools, which we'll talk about in a little bit, right? The pool, the reason you dam water is to simulate a pool in nature. So that still slow moving water allows sediment to fall out. So that works. But then it tends to fall where the water is pooled, which may be out in the street. It may be wherever it is. Filtering products, generally speaking, will allow the liquid to flow through them, hence the idea that they're filtering. And then they tend to look like this. They tend to have the debris, the waste, the sediment, even the silt, either around them or inside of them, but still allow the water to flow away. So we think there are some opportunities to use this in the real world, as it were, like in this picture, to get better results.
Craig, we do have one question.
Sure, absolutely.
Michael asked this question about 2 minutes ago, so it may have been the previous
Sure.
slide. He says, what is the surface area being measured?
So it's a square footage. So they'll measure, if you're talking about like the square foot of a product, so how many square feet it is. So obviously, like it's easier with the product is the whole circumference. So it's what's the whole surface area of the device. I don't hope that answers the question. I'm assuming he means from how much flow there goes through it. So obviously a smaller diameter product, it's going to have more linear feet to get to a square footage than a larger diameter product. I hope that answers the question.
He says, yes, thanks.
Oh, okay. I know that's, I'm not an engineer, so sometimes I try to answer and that doesn't always come out exactly what I want, but generally speaking, that's what we're talking about. Anything else?
Not at this time. Thank you.
Okay, great. So as I said earlier, much of this presentation normally focuses on how filtering and damming products perform differently. Often a log or a wattle or whatever's used, they're used with no regards to whether they dam or they filter the water, as I mentioned. And what I want you to get from today is just because two products look the same doesn't mean they perform the same. So in short, what this presentation we'll talk about more as we go through is how in many instances damming products are used. And again, we make damming products. We make lots of different products. So we're not picking on a brand or anything like that. What we're trying to say is there's often, we think, opportunities for a filtering product to be used where historically a damming product can be used. So that leads us to this research. Auburn University, as they're continuing to do, I should really update this, they're continuing to do a lot of research on this. And they talk a lot about the ditch checks commonly used on construction sites. They discovered that the inclusion of an underlay fabric reduced the potential for scour underneath the practice, thereby maintaining the interface between the practice and the channel. And their data confirms that the dense damming products can be successful in large-scale testing conditions by creating those longer subcritical flow areas. And like I said, we're not picking on a product. We're not trying to pick on a brand. We're just saying that there are damming and there are filtering designs. And we think that damming products are often used when really the goal would imply that a filtering product would be better. So a lot of this data, again, gets back to generally, I would say, the traditional sediment control of dirt, soil particles that have broken away, which doesn't exactly get into what we're talking about with trash and blowables. But I do think it impacts how it ends up in the real world and how it ends up moving or not moving those that waste around your job site. So why do you use a damming product? Mother Nature handles natural stream erosion through a series of pools and riffles that we talked about a minute ago. The erosion commonly occurs in those faster moving water in the riffles, but the particles settle out in the deeper, slower pools that follow those riffles. So damming products are used to mimic this concept. As I mentioned, just like it was in the street, the water hits the damming device, it blocks it up in that example, in that picture we showed a minute ago, and it pools up the water out into the street. Well, what that does is it protects the inlet, but the reason it's protecting the inlet is it's stopping all of it. It's not necessarily filtering it, and theoretically and hopefully it falls out in the street and doesn't end up in the drain. So in theory, the damming process by creating pools and ripples makes sense, but they're hard to recreate in the real world. There is not going to be a quiz, but I get this question from time to time when people are talking about how you space items. So it's just that to set the top elevation of the down gradient device at the bottom elevation of the up gradient device. So this isn't something you're going to get into in streets, but this is something in a channelized flow application, how we determine the spacing between the units. So damming products build up hydrostatic pressure as depth increases. This is not hard to understand, right? And that this buildup of energy can be the cause of scour under or around a damming device before ponding and overtopping occurs. So if all other things are equal, except for the depth of the water, there's more downward force in front of the device the deeper the water gets. So this is the old thing you've seen. It doesn't matter whether it's on asphalt or dirt or what it's on. If you dam water, the more water builds up, the more pressure there is, and water, as it does, finds the weakest point and tries to break through. The term we use in the Midwest here a lot is blowout. When blowout occurs, it's because the device couldn't withstand that pressure. So we're going to talk about where they blow out. And then, of course, this is where your sediment goes when they blow out, or this is where your trash flows to. So we're wanting to prevent that. So this simple figure illustrates what can happen as a result of increased hydrostatic pressure caused by ponded water. As the water depth, that we said, increases, the hydrostatic pressure increases, and the downward force generally causes scour directly under the damming device. As the downward force is increasing with the water depth, the weakest point in the channel becomes the path of least resistance. So we commonly see the weakest point being the channel being channeled under the damming device. So in a road outside of an inlet, right, there's no dirt, right? There's no interface in that regard, but there is a product sitting on top of the concrete or the asphalt. Well, sometimes those products don't work super well there because in the case of a straw wattle, for example, most manufacturers recommend that you trench out a little area for the straw wattle to sit into. If you look at their CAD drawings, that's what most of them recommend. And that's because they need it to have that intimate soil contact and they want it buried just a little bit. With sediment logs like we make on the filtering products, we don't need to dig a trench underneath them. Under our wattles, you do. So when the water's building up, the pressure often builds so much that it, like in this picture, it blows out underneath, right? This was trenched in. This was done on one of our rain slopes. That's one of our products. Water pressure built up. It couldn't withstand it any longer and went underneath there. So that's where the plastic bags are going to go. It's where the sediment's going to go. It's where anything that's going to go with that water path. And as you all know, it just it continues to get worse and worse over the course of an event. So it doesn't really matter which products. Again, let everybody know we don't make silt fence, but the purpose of this slide is not to pick on silt fence. The silt fence was installed probably as heavy duty as any silt fence would ever need to be installed. We have steel posts, we have wire backed. It didn't really fail. It didn't fail at all. It's just that the hydrostatic pressure built up so much that it blew out. So maybe this wasn't the right product to use in this application. And I also ask you to look off into the distance. There's no vegetation. And the reason there's no vegetation, it was because it was all killed. It all died from the ponded water behind it. So these are other things that we have to concern ourselves with. And of course, any waste, whether again, sediment, trash, whatever, just followed this and blew on down this ditch. Again, we don't make straw or hay bales, but we use straw in our wattles. I actually live in Kansas, even though I cover those other areas. There's for many, many years. I mean, this is how I was told out on the farm to take care of erosion. And while under very, very, very basic conditions, they might kind of help. They don't really hold up very well, and they're not very strong. A straw wattle isn't really any different, other than it's tied together in a long tube. So in that regard, I suppose it's more durable, but the characteristics of the fiber are still the same. And at some point, the ground gave way and it blew out. So more is not always better, you know. I mean, we said, well, we had a few straw bales, let's add more. Well, the same thing's going to happen. In most cases, it doesn't, in most cases, help much. It just wasn't the best management practice for this job. So people say, well, I used an underlayment fabric, or I used this really great installation technique, and I don't generally get blowouts underneath, and that's fine. But what's the next way we see these not working in the scour? And it tends to be around the damming devices. So the water depth increases, obviously, and over time. And if the installations aren't wide enough, the flowing water can scour around the sides. Generally speaking, as a rule of thumb, scour around a product can generally be stopped by installing the product about 3 feet above the normal pool on both sides. So, you know, this was the red lines kind of denote the original path on this project, and the rock check dam held up. The problem with it is this rock check dam, you know, it did what it was supposed to. You can see it's been filling up with sediment, and it would probably in slower moving waters held up pretty well. But then when a larger event happened, as the water built up behind it, they couldn't probably safely make this ditch check any wider, right? Because there's a road right there. You can't have the ditch check running up to the road. That's not safe. So this is probably as wide as they could do it. But an event occurred, and since this didn't filter anything, it just dammed it up. At some point, it blows around, blew that trash off. You can see the larger piece, but you can't really see it off in the distance. There's plastic, and there's a bunch of trash down here. And when we pulled over, there were two concerns. One was the blowout, of course, and the lack of vegetation, but then the other, of course, was the waste and stuff that had broke down. And you can't really see it, but way off in the distance where there's a shadow, it drops down into a little creek right there. So obviously this is what they wanted, headed towards the creek. Excuse me. So just as a reminder, this is, I think, a pretty good example of installing over the normal pool. Now, this was a really wide ditch, right? So they had room to install this the proper way. This happens to be a acrylic sediment log. I always like to say about this picture, one thing interesting about sediment logs and a lot of sediment control devices that filter, pay attention to your CAD files, because while with things like straw wattles that we make, the design tells you to drive the stakes through the center of the device, excuse me. With a lot of the products like acrylic sediment logs, you actually put the stakes through just the netting on the downstream side. And the reason is you want those fibers to expand and open up and allow that filter through the matrix. So just an interesting side note. Do we have another question?
Yes, Michael asks another question. What is the longest a filter log can last, and are they reusable?
It's Michael, you must follow me, because I get this question every time and I never probably give a great answer. So we have had sediment logs last months, and we've had sediment logs last days. Probably days is maybe short. In really extreme situations where there's no erosion control and a high sediment load, it is possible that a sediment log, depending on how many there are and so forth, could fill up in an event or two, right? They can. There'll be some pictures here in a little bit. You'll see them. They hold up pretty well, pretty far into their design life. So I would say probably on the short side, weeks. We do have a product out that is reusable, that comes in a really durable, high vis kind of wrap. It's a product that's designed to be used as perimeter control We call them a high vis wattle. They are meant to be reused. The standard Curlex logs are generally not reused. We'll talk about netting here in a little bit, but just a little precursor to that. The logs and the blocks have two wrap options. One of them is a degradable, I'm going to call it like a poly wrap, a mesh, and then the other wrap is 100% cotton. And we'll talk about those in a little bit. But in those regards, generally speaking, they're not reused. The one thing I do hear a lot about in the field of when they do fill up, the thing people like about them is they're easy to remove, and they generally just put another one in its place or set one just slightly upstream of where it was or upslope of where it was. So I know that's the world's vaguest answer, but generally not reusable, and depending on the setup load, I would say weeks to months on life.
And it looks like Jeff King, who's also with American Excelsior, has been chiming in a little bit in chat as well to kind of help support your answer. So
thanks. Yeah, I'm sorry, Jeff. I was scrolling through. Yeah, Jeff's on here. Jeff covers Oklahoma. So thanks, Jeff. I apologize. I didn't see that you were on. Okay. Any other questions?
Not at this time.
Okay. Awesome. Thanks. Hopefully Jeff gave the same answer I did.
Yes.
We're not experts, but we stayed at a Holiday Inn Express last night. Isn't that the TV commercial? So let's talk a little bit about a scour. So if the product, the damming product, doesn't have scour underneath or around, what happens next? So generally that's considered is overtopping. And so when overtopping is reached, a scour hole generally forms on the down gradient side of damming products if proper armoring isn't present. So that's what we talked about a little bit ago. Auburn and a lot of those places that are promoting some of these types of products say they work best, but you got to have, if you have armoring present. So that's to protect from these sorts of things. And the plunge pools, like at the plunge pool at the bottom of a waterfall, it's basically the same phenomena. When it overtops, this is what happens. And as the potential energy of the water increases, as that water depth increases and its position is increased relative to the bottom. So in this picture, hopefully you can see that with the spots where the product was removed. But this is a pretty common thing we see in the field. Towards the left, center left of the photo is the footprint from where I believe this was a straw wattle, but it was a damming device was. And on the right would be the down gradient side of where the damming device was installed. So there's a bare spot there, and then there's a scour hole below. So there's no vegetation downstream because of the scour, and there's no vegetation upstream because it was drowned out by the ponded water. So that's not obviously what we want. Vegetation is what we want in here. So could this have had different results if a filtering product was used? The Gabions in the field here did exactly what the designer wanted them to do. They ponded the water, then it overtopped. However, the energy of the overtopping water created this giant scour hole in the down gradient side of the Gabions, which eventually eroded a large section of the channel in this concentrated flow application. So there's all rework here. The Gabions held up, right? They did what we wanted them to do, but there wasn't armoring present to protect the bottom. And if there was, once this was established, you still would have had to deal with some vegetation replacement or repair, not as bad as we did here, but that's something that needs to be considered. I joke with everybody that I'm not a very tall person, and I'm not sure how tall this fellow is, but the scour hole formed on the down gradient side of this big rock check dam. And as I've said in all the other slides, it worked as it was designed to work, and it dammed that concentrated flow, but the channel just couldn't handle the energy of the water coming over the top when it overtopped. So it was wide enough, it was strong enough, but then this happened. So this isn't probably what we want to see along this roadside. So we mentioned earlier this Auburn research, and there's other people that have done it, requiring the underlayment fabric when you're using sediment control devices that pond water. And the thing to keep in mind, though, is vegetation doesn't grow where the fabric's placed, and the unvegetated areas are now unprotected. And obviously they create a situation where erosion can happen. So it's just something that if you're going to use a damming product, it's something you're going to have to address. We believe from our research at the lab and in the field, that the underlayment fabric method is an acceptable method in temporary erosion control applications when vegetation isn't really the goal of the project, or at least at that point of the project. Vegetation, as you all know, I'm sure, is one of the greatest tools in Mother Nature's toolbox, and it works really well in a broad range of erosion and sediment control applications. I was just on some vegetated waterways in Wisconsin 2 weeks ago. I'm not sure how much of that's being done in Oklahoma right now, but in Wisconsin, it's a huge movement to get farmers to put in these vegetated waterways. And there's a lot of really great reasons to do it. In addition to preventing the erosion, those vegetated waterways have cooler water temperatures. So the water that's coming out of them is much cooler relative to those coming across pavement or riprap. And they're safer, frankly. Obviously, you can drive across them. You don't have to worry about, many instances, they're even mowing these channels. So there's some great reasons to get Mother Nature and get vegetation back in play. The red dash line in the photo, just reiterating some of the things we've talked about. That damming device sitting there it's an inlet protection. So there's an inlet device. I believe, I think this is the one where it's kind of a silk fancy type fabric wrapped around a frame. Held up really well, right? It was designed well. It was designed to hold it. It looked like it overtopped some. The problem with this picture, the thing I don't like about this picture is, while it did protect the inlet device in that regard, the water stayed here so long that all that vegetation was drowned out. They obviously did a good job of planting. You can see the vegetation's growing every place else, but this is a concern, and it introduces this other weak spot. So this is something that's going to have to be resolved. And again, maybe with the choice of a filtering product, you might have had different results. So blowouts, we've talked about these. Again, it's just an example. They just can't, hay bales, I don't recommend hay or straw bales on anything except for hay rack rides. But they just don't hold up. So generally speaking, that in our research and our testing says that damming products may be suitable for in temporary channels where vegetation is not necessarily desired. But in our estimation and our research indicates that the basic concept of ponding water should not be used in channels that incorporate vegetation as a permanent component of the solution. Dense damming products have been shown to work really well in the field in sheet flow applications when properly installed. So again, nothing's perfect. Nothing works in every application. We make both of these kinds of products. I think that the filtering products have more applications than people think about them initially, and we'll talk about those next. So what happens when runoff in a concentrated flow hits a filtering device? So don't laugh too hard at my high dollar visuals here, but as the water flows through the device, the velocity is dissipated. And when the flow rate is exceeded, the sediment begins to accumulate on the upgradient side of the filtering device. So it will, in some cases, still accumulate on the back side, but it also accumulates within the matrix. Sediment and other contaminants are being retained within the matrix as filtered water is coming out the other side. So the question earlier about life, I don't know how long this product had been installed. I apologize. I should look this picture up, but it was well into its design life. This particular product had the degradable poly wrap on it. It had been there for quite a while. So there was a lot of sediment, leaves, you can see there. There's a lot of stuff hitting this, but we were still getting really clean water coming through it. And so it was probably nearing its end, but it is still cleaning the water. As long as clean water is coming out, as long as you're not blocking it up so far behind because it was so full of sediment, it's still doing its job. And then, of course, you're reducing velocity. And then what we see in the field is, like you saw in that inlet protection, if there is waste, the waste tends to fall in behind these sediment devices because they're following the flow of water. The water goes into the sediment control device, and the plastic cup or the can or the bag tend to pile up on the back of these. Again, good question earlier about functional longevity. Sometimes the functional longevity can be increased. People can go by and just do a little bit of a clean out along the back edges of these. And that's actually what we've been told in the field. Rebecca, I think you and I talked about this the other day. People are telling us that they make cleanup a lot easier because they just go to the sediment control device and they just pick up the trash off of them. And many times the product's still usable after that. So this is a good example of that. So this was a job site. You can see there was some silt fence still being used in the background. This product, it looks like to the right side of the picture, it looks like there was actually a little bit of sediment that had backed up quite a ways. But this big event put a lot of sediment through there. You can see that about 3/4 of the way up on that log, you can still see the brown, kind of brownish line on it. The water was up almost to there. So it captured a lot of sediment and allowed the waste and stuff to pile up in front of it. Again, we have been told these are really easy to clean up and clean around. And then the rest of that trash isn't gone down the street because the water wasn't rushing down the street in a river. It was still going in into the sewers as they'd want it to, but it was going in obviously clean. So why does this work? So this is just a time lapse of one of our straw blankets and then a piece of our Curlex. These are both our products. And this is what happens when these Curlex Excelsior fibers get wet. So whether they're in a blanket or in a log, they expand. And then just the opposite happens when they dry, they shrink back down a little bit. So when they're increasing in size, excuse me, I have hiccups. All of a sudden the mannings in, or the roughness factor of them in blankets, increases. So we're capturing sediment and so forth, and even in a blanket form. And then the logs, which are designed to filter water, they kind of open up, but they allow that water to flow through and capture that sediment within them. Again, it's not picking on straw. That's our blanket on the left. They just don't expand and contract like Curlex does. People ask what they look like when they take them out. This is really fine clay, which I know you all have some experience with. Stuff's hard to capture, and these sediment logs do a tremendous job at capturing that in the field. These are some that are broken up. We'll talk a little bit about this as we end the presentation here, but people always ask, well, what does your product do in regards to waste? So unlike, again, I'm not picking on it, unlike silt fence where you have to throw it in the dump and you're throwing away a bunch of plastic, you're not throwing away, if you buy our all natural wrapped product, you're throwing away no plastic. They're natural wood fibers and they're cotton netting. So there are many instances in the field where if it's a very rural area and they were installed with wooden stakes, we have installations where they don't take them out. But when they do take them out, there's no plastics. We're not adding any plastics to the environment or to the landfill. So this is a pretty common example of what they look like after their functional longevity has come to an end. We've done a lot of filtering device evaluations, and I put these pictures in here so you can imagine. Again, I know we talk a lot about sediment here, but the trash is going to do the same thing. So this is one of our 80-foot long trapezoidal channels at our test facility in Rice Lake at the Erosion lab. And so uphill, we ran a tremendous amount of water down an unprotected channel and hit this sediment log and a blanket installation to see how it would hold up to this huge flow. And we did have clear water coming out the back, but we did hit it with a lot of dirt on the uphill side. This is what happens in the field, right? So a pretty similar shot, but this is actually in real life. So they obviously hadn't gotten to put down erosion control yet. This was pretty severe, probably one of the more severe ones I'd ever seen. But generally speaking, the channel held up. It's going to need a little rework down, but it's not like it would have been if we would have dammed that up and those would have blown out. So again, still going to require some rework, but we think the better choice. This is what we want to see. We want to see, you can see in the very bottom front of the picture there, you can see the grass that was pushed up on these sediment logs. So there was some pretty high flows to this channel. You can't tell that now, but some pretty high flows. And this is what we want to see. The water was going away from us in this picture. And you can see that it filtered, it did a good job. Vegetation wasn't drowned out. And this is what we're hoping to see at all the applications. We've talked about all this. I know we're kind of running out of time here, but just as a reminder, filtering products are more than 35 gallons per minute per square foot, and the porous designs allowed to allow the water to flow through the matrix and capture the sediment either within it or upstream. little side note, I know you were talking about blowables and trash, but I thought you would find it interesting to note that Curlex fibers, these are the Curlex blocks. These are about the size of a bale of hay. As I mentioned, were designed to be an American-made alternative to coir logs. And we did a fly ash test. If you know anything about fly ash, there are lots of reasons to get this stuff out of the water. And we set this up in one of our channels. We pre-mixed fly ash, and these were the highest results we had seen as far as reduction of NTUs, and there were no flocculants used in this. So we had almost a 95% reduction in total suspended solids of fly ash. So again, in this application, if this was in the real world, the sediments being stopped or trapped within the matrix, as well as other contaminants, and hopefully allowing you to pick up any other waste and so forth that would accumulate along these sorts of stations. Another thing that we get asked a lot about is what other contaminants. So there's a lot of contaminants we don't see, right? Anything made with a Curlex fiber, a Curlex Excelsior fiber, has a EPA. We're listed on the EPA is an approved sorbent for oils and greases. So when you're specifying something that has Curlex fibers in it, you're going to be specifying something that helps remove PAHs, which are those typical components of asphalts, fuels, oils, and greases. So it's a nice added benefit. Just some short little videos here, but these are just Curlex fibers, nothing special about them. Dirty motor oil in water. And just a way to show you how quickly it grabs a hold of that oil. And just something to keep in mind, those fibers can and will grab that oil. Does a really nice job. So a little added benefit that other fibers aren't designed to do. So this is the end game, right? Clear water, whether it's keeping sediment or trash or whatever it is out of the system. This is what we're trying to do. As I mentioned, what happens to the Curlex logs and the blocks, that should say logs and blocks. The fiber's all natural. It's not a food source. It's not a byproduct. So it is completely safe. The netting can be degradable or 100% natural. And in some instances, they are left in place, and you can confidently say that you're not adding any plastics to the landfill. I've hit all this, so I'll stop now, but I want to say how much I appreciate your all's time. I hope this has been educational, and I'd love to answer any questions that you might have that Jeff probably hasn't already answered for me.
We haven't had any more questions come through, but thank you to those who did provide those questions for us. It's always nice to have a little audience interaction, of course.
Absolutely.
Craig, thank you. Such great information. I always enjoy your presentations because they are very informative. So thank you so much for your time on that. Up next, our Community Relations Coordinator, Brooke Varick, will provide a very short little piece of information on local programs that help keep our community clean. So Brooke, if you'd share your screen, and if we see some other questions, we did get one pop in while Brooke is getting ready to share her screen. Somebody asks, Michael Jordan asks, where are your products available?
I'll let Jeff answer that in the chat. We sell through distribution throughout the country. I know we have good distribution in the Oklahoma area. So I'll let Jeff answer who he uses, but we use distribution. And then if you're doing work outside of Oklahoma, we can obviously get you the right names to contact for materials.
Okay. Yeah, we'll post that into chat. And if for some reason they aren't able to get that answered, I did post our guest speaker's contact information into chat. So if you guys have other questions, feel free to reach out to Craig directly. All right, looks like Brooke is ready. So Brooke, I will let you do your presentation.
Thank you, Rebecca. All right, this is going to be a little bit of a review from last month. So if you were on last month's webinar, then you already saw some of this information, but we're going to keep it pretty short and quick today. I just want to highlight a couple of our outreach programs that we have going on right now. They are in full swing, especially with the nice weather, the warmer temperatures. Our Adopt a City Street program is going real strong, where we've had lots of groups participating in litter cleanup events during the week, on the weekends, for their adopted roadways. Our Waterway Clean Sweep was pretty strong in the spring. It's slowed down a little bit for the heat of summer, and looks like it's picking back up for the fall. And then Curbs to Creeks, our storm drain marking program. Our Waterway Cleanup, some of our spotlights, we wanted to spotlight Bowen's Waterway Cleanup. They had 15 total volunteer hours. They collected about 32 bags of trash with 899 total pounds of trash for their collection. And this was a picture from DEQ's Waterway on this slide. They had about 72 total volunteer hours, 111 bags of trash, which was an amazing record, and over 3,100 total pounds of trash. And then our last community cleanup we held at Walker Wetland, and they had 30 total volunteer hours. They collected 58 bags of trash for a total of almost 1,300 total pounds of trash. So if you're a company or you have a group of people that are interested in scheduling a waterway cleanup event, especially for the fall, we're setting them up now. It'll be a little bit cooler, and we have lots of different waterways that look extremely trashy, like this one in the photo, that need some tender loving care. We did hold our rain barrel pickup event on May 8th and May 15th. We distributed over 374 rain barrels for OKC, and it actually ended up being over 900 rain barrels for the total OKC metro between Norman, Yukon, Midwest City, Edmond, Mustang, and OKC, and I may be missing a couple as well, but over 900 metro wide. This was the numbers from our special collection event. So we did have about 454 residents come through to participate in the program, with lots of tires, ammunition, medication, and computers that were collected. So those are some of the numbers if you're interested. And then again, if you're interested in setting up a volunteer opportunity, feel free to reach out to me. We can get something set up for your organization, and we can kind of mold it to what your needs are. So feel free to contact me if you're interested. And I will turn it back over to you, Rebecca. Thank you.
Great. Thanks so much, Brooke. If anyone has any questions for Brooke, please feel free to type them into chat, or I've also put her email address into chat. So if you want to reach out to her later, feel free to do that. As a reminder, if anyone would like to receive a certificate of attendance for today's presentation, please send an email to Brooke to request that. We ask that you don't request certificates in chat because we may or may not have your email address linked to your username on Teams. So just please, again, send an email to Brooke to request that. We should be able to get those out hopefully this week. As I've mentioned, a recording of today's presentation will be available on our website in the next week or so, and I will post a link to that in chat at this moment. You should be able to pop back into this meeting and click on that link anytime. So that will be available as a resource for you. Thank you all for attending our session today. We hope everyone enjoyed the presentation. We will see you next month on July 20th at 1 p.m. for the next installment in the Floatables webinar series. The presentation will be another installment from the Industrial Stormwater Program, and we'll be able to introduce to everyone our new Industrial Section Supervisor, Chris Stewart. Have a great afternoon, everyone, and we'll see you next month.
Thank you.
Thank you. If you want to hang out for just a minute, Craig, just in case someone else has any questions.
Oh, sure. Yeah, stay on as long as you want. No problem.
Okay, cool. Let me get the recording stopped.